Hi, I am Rajendra Kulkarni. Welcome to my channel Programming in C with RSK. In this video, I will be discussing about arithmetic operators in C. I will also discuss how to take inputs from the keyboard using scanf function. Scanf function is used for taking inputs from keyboards. The inputs that are entered by the user are assigned to the variables which we have, the names of which we have to supply to the scanf function. We have to write in the scanf function the names of the variables to which we want to assign the enter values. Here is a small program which can explain us the scanf function in a better way. The first statement is always hash include stdio.h. It is called a header file. Then starts main, then the opening brace. We have declared three variables here: int ival, float fval, and char cval. Then the program is prompting us to enter the values for these three variables by printf function, which says into the bracket and within the double quotes enter values for ival, fval, and cval. Now comes the scanf function. In scanf function, what we have to do is first enter the format specifiers for the variables to which we want to assign the values. Now in this program, %d stands for an int variable, and we want to assign the entered value to int ival variable. %f stands for float variable. %c stands for char variable. After putting a comma, we have to enter the variable names to which we want to assign the values. Here the first format specifier we have entered is %d, which stands for int variable. So naturally the first name of the variable that appears in the scanf function will be ival, and ival is attached with a ampersand. This is a must. Ampersand is called the address of operator. Address of what? Address of the variable to which this ampersand we are attaching. Comma and ampersand fval, comma ampersand cval, and end of parenthesis and a semicolon. This function printf gives us on the screen the values which we have entered. Ival is equal to %d, fval is equal to %f, cval is %c, and the names of the variables ival, fval, cval. Now this is the screenshot of the output screen. After executing the program, what we are getting at the output is first this printf prompts enter values for ival, fval, and cval, to which we have entered 1, 2, 3, 4 as the value for which we want to assign to ival. 6, 7, 8.9 is the value which we want to assign to fval, and z is the value which we want to assign to cval. After doing this, then another printf statement we have written. It gives the entered values, displays the enter values on the monitor. So this is the values which we have entered, which are appearing onto the screen after the program is executed. Please note, while using a scanf function, we have to first write format specifiers within the double quotes, then the comma, and then the names of variables with ampersand. Ampersand is called the address of operator. Scanf function's prototype is defined in the standard stdio.h file. We have to include that file for getting the scanf and printf functions data types, prototypes. What happens whenever the program is executing, on reaching the scanf function, program halts and waits for inputs from the user. So whenever there is a scanf function, program will halt there. It will go ahead only when the inputs are supplied by the user from the keyboard. Why ampersand is called address of operator? Because it gives address of a variable. While using scanf, it is necessary to enter first the format specifiers, which we must write within the double quotes. For the variables, which format specifiers? The format specifiers for the variables which we want to which we want to assign the entered values. After double quotes comes the comma. After comma, variable names are written along with attached ampersand symbol to each variable. Many times it happens, it is a problem, especially when we want to enter, or whenever in a program we want to enter a char value. While using scanf, the data received in input buffer from earlier scanf function. So whenever the keyboard inputs are obtained, or whenever the keyboard inputs are given to the program while using scanf, sometimes it may appear that the data that is going into the buffer will not clear completely, and this gives unpredictable behavior of a scanf function. There is a function called fflush which clears the input buffer. Its prototype is also declared in stdio.h. By using fflush function before using scanf, the input buffers will get cleared, and the issue that sometimes we may face will not be appearing. While entering the values, those should be separated by space or a tab, or may be entered in a new line. There are certain data types which are available to us. The C has made available many other data types other than int, float, char, unsigned int. There are some more data types. We will see those data types here. In real life programming, the values which involve may be much more than the what primary data types can hold. We know int has a limitation. Int variable cannot hold more than 32768. When our program wants to handle the variable, the values which are more than this, we need some other kind of variable. Those other kind of variables are long int, unsigned long int, double, long double. These data types hold much bigger values than what primary variables int, float and char can hold. In the next slide, we will see the data types and the format specifier for these variables. The first data type which we have already seen is char. When no sign is mentioned, the default is taken as positive. Its range -128 to +127. It occupies 1 byte in the memory, and its format specifier for printf and scanf functions is %c. Then unsigned char. It has a range 0 to 255, only 1 byte, and format specifier is %c. Then there is short int. When no sign is mentioned, it is taken as positive. Its range is -32768 to +32767. It has 2 bytes allotted to it, and its format specifier is %d. Then there is unsigned int. As there is no sign required for the values, we use unsigned int. Its range is 0 to 65535. Bytes are 2. Format specifier is %u. Then there is a long int. Long int is a data type which is allotted 4 bytes in memory. By default, when there is no sign mentioned, it is taken as a positive. Range is this much. It's a big range. Use a range. And format specifier is %ld. L small. Then there is long unsigned int. It gets 4 bytes in memory. %lu is the format specifier. Float we have used up till now many times. 4 bytes in memory. Format specifier is %f, and the values are like this. Then there is another data type called double. It gets 8 bytes in memory and its format specifier is %LF, L small. You can see the value it can hold, minus 1.7 e raised to 308 to plus 1.7 e raised to 308. So huge value. Then there is another variable, data type, which is long double. As we have long int, there is also long double. It gets 10 bytes in memory. Value is this much. It can hold such a huge value. Format specifier is %LF, where L is the uppercase. How to use those format specifiers in the program? In this small program, we are going to look after the format specifiers and using these data types which we have seen in the earlier slide. Long A is equal to 1, 2, 3, 4, 5, 6. Long A is a short form for long int A. We can write long int A or we can simply write long A. It's one and the same thing. Then unsigned long B. Double C. C is a variable of type double. Then there is a statement, enter value for long unsigned B. Now this value we are entering from the keyboard. So we are using scanf function and the format specifier for long unsigned int is %LU, where L is a small case, and that value we are assigning to B by writing %B. Then we are taking value from keyboard for variable C, which is of type double. Another scanf function, when the user enters the value from the keyboard, scanf will assign that value to variable C, and the format specifier for double is %LF, where L is the small case. Then the printf statements, which will give us the values displayed on our monitor. Long int A is equal to %LDA. Long %LD is the format specifier for long int. %LU is the format specifier for unsigned long int. %LF is the format specifier for double. Now watch this. A is equal to 12 and L in capitals. What makes 12 is a small value. It can be accommodated in a int, but in my program I want it should be a long int. So by A is equal to 12L, 12 becomes a constant of data type long int. This printf statement, A is equal to %LUA, will give us the value of A, and %LU is the format specifier for long int. %LF is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LF is the format specifier for long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long int. %LU is the format specifier for unsigned long on the monitor screen. Now see the output from this program. It is a screenshot. For a prompt, enter value for long unsigned B. We have entered this value 1, 2, 3, 4, 5, 6, 7, 8. For double C, we have entered 4, 5, 6, 7, 8, 9.11. For long int, A is equal to 1, 2, 3, 4, 5, 6. It is the output for A, which we have already assigned with a value of 1, 2, 3, 4, 5, 6 in our program. Unsigned long int B is equal to 1, 2, 3, 4, 5, 6, 7, 8. This value we have assigned through a keyboard using scanf statement. Double C is equal to whatever value we have entered. The printf statement is giving us a display of that value on the monitor screen, and A is equal to 12. We have assigned A 12, but what we have done is it has been we are telling compiler that A is a long int to which we are assigning a small value, but that value should be taken as a long of data type long. %lu for unsigned int format specifier, %lf for double, %ld for long int, lu for long unsigned, ld for long int. By writing 12 and putting a capital L after 12 makes it a long int. There are arithmetic operators which we are going to see in this slide. Let us consider an expression int A is equal to 15 divided by 4 plus 45 minus 12 into 2 plus 12, then modular division 12 mod division by 5. In this expression, the value of A will depend upon the way this expression is evaluated. There are 1, 2, 3, 4, 5 operators in this expression. Which operator should execute first? Its priority is decided by a rule of precedence. See, there are two rules by which the arithmetic operators are governed. The first rule is precedence rule. There are many operators in C. All those operators are grouped in more than 10 groups. Operators for multiplication, division and modular division are grouped into one group, and that group is called multiplicative group. Addition and subtraction operators are grouped into another group called additive group, and it has a lower precedence than multiplicative group. So the plus and minus operators in the expression will have a lower precedence than the multiplication, division or modular division operator in the arithmetic expression. Assignment operator is one more group, and it has the lowest precedence. So it will execute last in any arithmetic expression. Operators within the group has equal precedence. So in multiplicative group, multiplication, division and modular division, they are having a equal precedence. There is no priority or there is no lesser priority. Associativity is the other rule for evaluating a arithmetic expression. Multiplicative and additive operators associate left to right. That means they will be evaluated from left to right in an expression. Assignment operator associate right to left. That means the value to the right of assignment operator will be assigned to a variable on its left. From right, value to the right of equal to sign will be assigned to a variable on the left of assignment or equal to sign. Now the previous, whatever this expression int a is equal to 15 by 4 plus 45 minus 12 into 2 plus 12 mod 5. How this will evaluate? As we have seen earlier, expression appearing after the assignment operator. This is the assignment operator. So whatever is the expression to the right of assignment operator, it is evaluated first. All the operators in this expression, in this particular expression, associate left to right. So first 15 by divided by 4 will be evaluated. Since this is int constant, its value will be 3. On evaluation of by 15 by 4, the resultant value is 3. In the next evaluation will be 12 into 2, which is 24. 12 into 2 evaluates next. First 15 by 4, then 12 by 2, 12 into 2. Then 12 mod 5. Modular division gives the remainder as the output. Ultimately, a is equal to 3 plus 45 minus 24 plus 2 will be the expression which gets evaluated after the multiplicative group operators have been executed. So 3 plus 45 will first execute, that gives us 48. Then 48 minus 24 will execute, resulting into 24. And lastly 24 plus 2 will be evaluated, and hence a will be assigned with a value of 26. As we have earlier discussed, precedence of operators and associativity are two important rules compiler follows while evaluating an expression. Now let us see a expression a is equal to 10 into 5 plus 2. There are three operators in this expression. Assignment operator is equal to multiplicative operator and additive operator. Now which operator evaluates first, that will give the resultant value of this expression, which will be assigned to A. Since assignment operator is associates from right to left and executes last, hence only after the expression appearing to the right is evaluated, assignment will take place. As per the defined precedence, 10 into 5 will be evaluated first, then 2 will be added to the product of multiplication, and lastly the resultant value will be assigned to A. If we write the same expression in another form, A is equal to 2 plus 10 into 5, the expression also evaluates the same as that of 10 into 5 plus 2. Both evaluate to 52. In this case, A is equal to 2 plus 10 into 5. 10 into 5 will first evaluate. That gives us a result 50. To this 2 will be added and ultimately A will be assigned with a value of 52. Let us see a program which demonstrates various arithmetic operators in C. In this program, we have declared three variables, int a, float b and char d. Then there is an expression, a is equal to 7 by 5, 7 divided by 5. And we are taking the output of this expression by printf statement, a is equal to %d a. Now what will be the output? What will be the value of A? Since 7 and 5 are both int constants, the expression will evaluate to 1. 7 by 5 will be evaluated to 1. And since A is also an int variable, 1 will be assigned to A, and what we get is A is equal to 1 as the output. Both operand being type int and result is also being assigned to a int. In this second expression, b is a float variable to which we want to assign the result of a arithmetic operation or arithmetic expression 7 divided by 5. Again 7 and 5 both are int constants. The 7 by 5, 7 divided by 5 will evaluate to 1, and the printf statement will give us b is equal to 1.000000. Here we are getting in the first a is equal to 1, here we are getting b is equal to 1.000000. Now in this third statement a is equal to 7.0 divided by 5. Here a is a int variable to which we are assigning a value which will be a result of an expression 7.0 divided by 5. Since out of these two operators 7.0 and 5, 7.0 will be treated as a constant of type float by the compiler, and the output will be 1 again, a is equal to 1. Actually the division will evaluate to 1.4 because when one of the operand in an expression is of type float, the second operand, even if it is of type int, it will get promoted to a float and expression will evaluate to 1.4. But since we are assigning the expression result to a, which is a int variable, our output will be again a is equal to 1 because a int variable cannot hold a value of type float. 1.4, even if we assign 1.4 to a, it will hold only 1 as the value. Whereas when we assign the value evaluated by expression 7.0 by 5 to a float variable, what we get is b is equal to 1.400000, because 7 is a float, 5 even though it is an int constant, it will get promoted to float, and the expression evaluates to 1.4, which again is assigned to a float variable which is capable of holding a value of 1.4. In this expression, a is equal to 7.0 divided by 5.0. Both 7.0 and 5.0 are the float constants. They will evaluate to a 1.4, but again the value of that division is being assigned to a int variable which cannot hold a float value. It will only hold, instead of 1.4, it will hold 1, and we will get an output a is equal to 1. Whereas in this expression 7.0, 5.0 are both float, and the result of division of these two is assigned to a float variable. So b is equal to 1.400000 will be the output. Now here we are using, in this expression what we are doing is 7 mod 5. It is a modular division, 7 divided by 5 in modular form. When a modular division takes place, the result is always a remainder and not the quotient. So when 7 is divided by 5, 1 will be the quotient, 2 will be the remainder, and that 2 will be assigned to a. And since a is a int, a is equal to 2 will be the output of this expression. B is equal to 7 mod 5 gives us 2 as the remainder assigned to a float variable b, and the printf statement will give us an output b is equal to 2.000000. When we try to do modular division on float variables, there will be a compile time error. The error states illegal use of floating point, because in C, modular division on floating point operands is not allowed. In this arithmetic of char, we are trying to find out how char variables can be used in an arithmetic expression and what are the outputs of those expressions. Here we have declared int a is equal to 10, b is equal to 55. These two are int data types or int variables. Then we have declared a char variable ch and assigned a value of uppercase A or a capital A to this ch. Then we have declared fourth variable char type bb, char bb. When we do bb is equal to ch plus 25, what we are doing? We are adding 25 to a char variable ch, which is already holding value a. The output will be bb is equal to z, because 65 is the ASCII code for a, which is assigned to ch by a statement ch is equal to a. To 65 we are adding 25 and the resultant is 90. 90 is the ASCII code or ASCII value for capital Z. So what we are getting is printf statement bb is equal to %c bb gives us a display of bb is equal to capital Z. Now in this statement ch is equal to a plus b, what we are doing? To ch there is a arithmetic expression a plus b, the result of which will be assigned to ch. Earlier ch was assigned with a, capital A. Now ch is getting assigned with a value a plus b. A is equal to 10, b is equal to 55. So ch will now hold again a plus b's evaluated value 65. Now we are trying to take out the value of ch after ch is equal to a plus b is evaluated. So when we use ch is equal to %d, the output will be the ASCII code, ASCII value 65. When we use ch is equal to %c, what we get is a char value of capital A. See, ch is being same variable having the same value, but when we try to take out its value by a printf statement, format specifier %d will give us a int value, which is the result of evaluation of 55 plus 10 a plus b, and a format specifier %c will give us a character a as the output. There are many expressions where there can be a tie in precedence. Let us see one more program. Int a is equal to 10, float b is equal to 20.5, and third variable is declared as float result. Result is a float type of variable. In this expression, we are trying to find out the resultant value of a arithmetic expression a into 10 divided by 5. Since a into 10 by 5, multiplication and division operators both have equal precedence, and since multiplicative operators associate left to right, what will be the result? A will be multiplied by 10 and it will be divided by 20.5. So it will be 100 divided by B, which has a value of 20.5, and results yield will be 4.878049. Now in this expression, A divided by into parenthesis 10 divided by B. Parenthesis has the highest precedence. So the result will be first 10 divided by B, which will be again there's 10 divided by B. The result of this expression will divide A by the result. A divided by 10 by B will be the final expression evaluated to 20.500. 10 divided by B will be 0.4 something, and then A is 10, so resultant will be 20.5. Another expression, result is equal to A into 10 plus 30 into A by B, A divided by B. The output will be 114.634148. The first step that will take place is A into 10, which is 100. In second step, 30 into A will be evaluated, will be 300. Then this 300 will be divided by B, which is 20.5, which comes out to 14.634. Lastly, the plus operation, the plus operator will execute, and 100 plus 14.634148 will yield a result of 114.634148. This is the screenshot when the program was executed on a compiler. When there is an ambiguity, which means which operator will execute first, such an ambiguous situation is resolved by the rule of associativity. Left to right associativity means operand to the left of an operator. Operand to the left of an operator should not be involved with another operator. And then that operator, operand, is unambiguous. I will repeat it again. Left to right associativity means operand to the left of an operator should not be involved with another operator. Now take this example. This will explain us in a better way. In this example, the expression is 5 into 10 divided by 20. Now what will execute first, 5 into 10 or 10 divided by 20? What will execute first? Which operator will execute first? In this expression, the operand to the left of operator is 5. The first operator is multiplication operator, and to its left is a operand 5. Since 5 is not to the right of any other operator, 5 here is unambiguous. It is clear that 5 will have to associate itself with this multiplication expression. Operand 10 has operators on both left and right side. So it is ambiguous. Compiler will not clearly understand what to do with such kind of situation. So there is a ambiguity in this operation, in this expression. 20 is unambiguous. It is clear as it has no operator on right. So 5 and 20 in this expression are unambiguous. 10 is ambiguous. Since 5 is ambiguous and there is a left to right associativity, 5 into 10 will be performed first. So these are all about arithmetic expressions. Thank you for watching. The next presentation is on decision control structure, if, else and switch. I will be uploading many videos on all the topics in C. Please like, subscribe and share the videos. Thank you.